It's 2026 and everyone I know has agents writing all their code. The modern dev is only constrained by how fast they can verify this code. How do I know my app is correct? And even if my AI written tests pass, how do I know the tests are testing the behavior I had in mind? And then the more I build, the more brittle my app seems. So I end up spending hours sending screenshots back and forth with my agent to address broken features from 3 months ago. The final mile always takes 90% of the time. Ripplo solves these problems with its core primitive, workflows, my users' critical paths in my application. On screen is the Ripplo dashboard running against CalDIY, a large open source full stack app. Every green dot is one CalDIY workflow. Ripplo automatically generates tests from each workflow that validate my click path step by step, front end, and critically back end mutations as well. In this workflow, I expect a new booking and a $50 payment and no other database changes, and Ripplo confirms that. My Ripplo tests are deterministic and parallelizable. Every run gets freshly seeded state, so results are consistent and flake-free. Ripplo workflows are defined by coding agents, either with agents in my IDE using Ripplo plugins or via the task queue in the Ripplo UI. But asking a coding agent to verify its own work never quite works out. They write shallow tests that seem to always pass on the first try. These tests typically confirm the obvious and don't validate any of the tricky cases. Ripplo uses a combination of static analysis and behavior modeling to guard against this. Because workflows often share states, navigations, and click paths, Ripplo connects them into an application model and starts making inferences. Look at this confirmation step. It was never written into the workflow, but Ripplo saw the same check in another workflow that starts from the same setup and has the same navigation, so it knew that step applied here too and added it automatically. Ripplo can also learn invariants, like tying a global parameter to the UI to confirm it always renders. This connected model lets Ripplo test beyond the paths my agent wrote. Ripplo's Explorer chains my workflows together in the background, like cancel an upcoming booking, toggling off of my calendar notes, and delete the last schedule, and then runs them together in combinations I never thought to check. That's how it finds the edge cases users hit, but developers never seem to. Explorers run in the cloud or on my machine, and everything they find lands straight in my agent's task queue. Here's what this looks like day to day. Scrubbing through a workflow's playback frame by frame, I spot a weird state mid-transition. Ripplo already understands my workflow, every element, every mutation, and especially across time. So I can drop a comment on that exact frame. My agent picks up the task from Ripplo, fixes the UI, verifies the fix against the workflow end to end, and makes sure the rest of the Ripplo workflows continue to pass. I get back proof of the loading state fix and passing workflow that gets validated on every future push. Together, my workflows become a legible catalog of my application's behavior that I can validate every time I push a new feature, which preempts regressions before a user ever touches the application. And once I have a catalog that defines and confirms my application's behavior, Ripplo gives me agentic reviewers that catch all the visual stuff, accessibility, UX, and copy editing. So while my agent builds fast, Ripplo handles the validation for me so that I can be confident my application still works for my users. You can try Ripplo with one terminal command, npx Ripplo setup, and Ripplo will create your initial workflows for you, no manual configuration needed. If you have any questions, you can message us on Discord using the link in the video description, and we hope you enjoy using it.